Imagine a robot matching your moves on the badminton court, outmaneuvering you with 4 legs and a racket. Sounds like science fiction? Think again. The world of robotics just reached an extraordinary milestone. And not everyone agrees on where this technology might take us. Researchers at ETH Zurich have accomplished something remarkable. They have trained a 4-legged robot, ANYmal, to play badminton with human-level flair. But here's what sets this story apart. ANYmal doesn't just whack the birdie at random. It is programmed to seamlessly blend movement, perception, and paddle control in real time to predict, track, and hit the shuttlecock with precision, just as a skilled human might do. For most robots, the lightning-fast pace of sports exposes their biggest weaknesses. Coordinating limbs, eyes, or cameras, and quick decision-making all at once is a feat even advanced machines struggle with. Especially in unpredictable arenas like a badminton court. In badminton, the shuttlecock rockets back and forth at high speeds, and the player's or robot's footwork is just as important as their swing. This combination of speed and agility makes the sport an ideal test case for robotic coordination and an ongoing source of debate in the research community. Can robots ever truly move like us? The ETH Zurich team came up with a groundbreaking solution. They taught ANYmal using a single, unified reinforcement learning system. This allows the robot to simultaneously interpret visual information, move its legs with purpose, and swing its arm with accuracy. But here's where the real innovation comes in. They trained the robot using what's called a whole-body visuomotor strategy, meaning it uses all its joints, sensors, and limbs together to track and intercept the shuttlecock in one fluid motion. A particularly clever twist, one you might not expect, was the inclusion of a perception noise model in training. In the real world, cameras have flaws. They blur, glitch, or lose focus. Rather than ignore this, the researchers simulated these imperfections while teaching ANYmal, forcing it to adapt just as a human would when vision isn't perfect. The robot learned to reposition itself, tilt its head, or adjust its stance mid-game, all to get a better lock on the flying shuttlecock. Another fascinating detail. ANYmal uses a shuttlecock prediction algorithm to estimate where the next shot will land. Pairing this with constraints in reinforcement learning, the robot learns not only how to move efficiently on the court, but also how to hit the shuttlecock accurately, even against human challengers. And this is the part most people miss. Tests proved that ANYmal could maintain balance and agility on the court, handling rapid shifts and chaos typically too complex for most legged robots. But here's the controversial bit. This technology isn't just a fun parlor trick or a game. The ability for a robot to coordinate movement and senses in such a complex environment could revolutionize fields like disaster response or industrial inspections, where agile, perceptive robots are needed most. Still, some wonder, should we be training machines to outplay us in our own sports? Or should we focus on areas where their abilities can save lives? Does the idea of a robot partner, or rival, on your local badminton court excite or worry you? Should this research be used to build better companions, or do you see other, possibly riskier paths ahead? Let's get the debate going. Share your thoughts, and let's discuss the future of robots in human environments.